Hello everyone. I'd just like to let you know that your audio is working, so at least you know that before we start. We've still got 2 minutes to go, so we'll wait a bit for other people to join and then we'll start off in 2 minutes. Thanks a lot. Talk to you in a bit. Hello everyone. It's great to have you all here. This is Niels de Noever, the head of digital of Article 19, and I'll be doing the webinar together with you today. I have to say this is the first webinar I give, and it is really quite strange to talk to a group of people without seeing or hearing them, but I'll just give it a go. So I would like to ask you, since we're also tackling quite some technical issues today, that if we come across something that you might have a question of, either technically or otherwise, please put a message in the Q&A box, and I'll try to get back to it as soon as possible. So interactivity is really very much appreciated. I was also asked to let you know that this session is recorded, so all your contributions will be recorded officially. And I was also asked to remind you that this is a preparation webinar for the global conference on cyberspace held in The Hague, which is part of the London process. And the cybersecurity definition that we'll use, as mentioned in last week's webinar, which was the first by Tim Mauer, we'll use the cybersecurity definition as produced in the working group as follows. International human rights law and international humanitarian law apply online as well as offline. Cybersecurity must protect technological innovation and the exercise of human rights. That was the preamble, and then the definition is cybersecurity is the preservation through policy, technology, and education of the availability, confidentiality, and integrity of information and its underlying infrastructure, so as to preserve the security of persons both offline and offline, which is inspired by the ISO 27000 standards. But the real question is, what does this mean? And how does this work out in practice? I will focus today only on the technical bits and architectural aspects, not so much on the legal aspects. I'll just try to point out that even though we have text, for instance, in a Net Mundial declaration, that internet governance and the managing of the internet should be based on human rights, it's still to be found out exactly what this means. And this might even be more true when it comes to international humanitarian law, but I'll try to touch upon that in a bit. We will be focusing today on system security and what it means that there are systems that are connected to the internet, how they can be kept secure, and how reactions to insecurity should be done. The internet is a network of networks that gets defined by using the internet protocol. The internet protocol, also known as TCP/IP, is actually a suite of protocols used to communicate. The most crucial part of this infrastructure is packet switching, also called TCP. This technology was invented to make a network that should be resistant to nuclear attacks. So when people talk that governments came very late to the internet, well, that's actually not true, because the American Department of Defense played a very big role in the defining of and the development of the internet. So before there was packet switching, information was sent in streams. And if there was any noise on the line, information would get lost and a whole pack would need to be sent again, very much like a phone conversation. Packet switching makes this different. Packet switching cuts up packs of information in small packs, little bits. And these bits are called packets or datagrams. If you want to envisage them, think of them like a truck, where the back side of the truck, where all the cargo is, that's the actual content of the message. And then in the cabin in front, where the driver is, there is some information on where the packet's coming from, where it wants to go to, and how it identifies itself. Secondly, it then gets routed over the network, and that's done via the IP protocol. And then you might think, but yeah, all these packets need to arrive to put it together again, right? Well, that's not necessarily the case. Many packets get lost every day on the internet. Actually, every day there is a packet genocide on the network. But that doesn't matter, because it can simply be requested that packets get sent again. And this happens all the time. This makes the internet work like a chain link fence. It's a distributed architecture to which packets get sent all over, get lost, and get resent again. So now let's get back to systems. What does this mean? Well, if we try to define it in terms of security and rights, then security is the state of being free from danger or threat. But when we try to define this in terms of computer text, then we want to understand what's going on the systems that we run, and also control what can be done on it, or rather, what cannot be done on it. So we will really need to think that you can either have a positive or a negative definition of security. The earliest computers could only do one thing, or two things, or three things, and could do all these things very well. But our modern day computers are used for many, many different things. This makes it much more difficult to know what's going on your system. You might have ever opened a process browser on your computer, and then you see hundreds of different processes running at the same time. Some of these processes might be good, some of them might be bad, some of them might be initiated by you, and some of them are not. This makes it really difficult. And then it gets more difficult that many processes are also kept hidden from you. And then there is even the hardware layer, because you can see in the software layer, so that's all the programs and code that is running on your computer, what's running. But hardware might actually also perform functions that you're not completely aware of. So this makes system security very hard to make sure that your system is transparent, autonomous, and that you are sovereign, and that you can have sovereign control over your system. And then it comes the most hard part of system security, and that is users. Because computers can be made to listen to rules and to adapt to that and follow the rules up very strictly. But users tend to use programming and computers in ways they were not designed. And that's excellent. That's creativity. That's how we make progress and find out new things. But it's also really hard to make a system secure that someone is doing all kinds of things on that you did not expect. We'll get back to that in a bit. So now if we think of system security, that was already hard, by also adding internet to the mix. This makes the whole picture much more complicated because all of a sudden you have many more processes. All these packets that are coming from all over the internet, knocking on the doors of your computers, services that are being offered, some of which you might want, some of which you might not, some of which you might not even know what they are. And this is the interesting of the internet. We have not defined what the internet should be doing. And that is what's making the internet a great source of creativity and innovation, which we have not nearly exhausted. It's an engineer's playing field. But at the same time, if we do not know everything that might happen, there's also quite some risk involved, because how can you prepare for all these things that might happen? Also good to keep in mind, think back of how packet switching was designed, is that the internet was built with the thought of resilience in mind, so that it could not be shut off. But it was not built with security in mind. So security is always a layer that's built on top of the network and is not inherited. And we do not want to limit the possibilities online because we want the internet more than to be a one-thing machine. But at the same time, freedom of expression in the internet also needs freedom after expression. And security is also a right, such as just like privacy. So how can we ensure these things online? And what's the role of the different actors in that? Well, there are definitions for that. The IETF, which is the Internet Engineering Task Force, which sets the internet standards and protocols, has a standard about internet security. And it starts off by saying that the internet is a voluntary network. So people can choose to connect to the network. They do not have to. But we can doubt that increasingly because more and more essential services for us are provided only via the internet. Think of increasing amount of government services or other services that you might need. So we might need to connect to this network, of which the presumption is that connection is still voluntary. Then the RFC continues that each participating network takes responsibility for its own operation. And service providers, private network operators, users, and vendors all cooperate to keep the system functioning, often on a best efforts basis. Well, this means that everyone, when you are connecting to the internet, you have responsibility over your own security. But when we think back to what we said earlier, is that there are many very complex processes going on. So how can you keep yourself secure without knowing everything that's going on in computers and on the network? That's a big and hard question, especially if we see that via user research, and this is a quote from the early 90s, giving a choice between dancing pigs and security, users will pick dancing pigs every time. And actually there has been an experiment doing this actually in a browser by giving people a warning. Would you like to give up your security, or would you like to see dancing pigs? And actually over 80% of the users simply wants to see the dancing pigs. So when this becomes so hard, how can we approach this? Well, this is not something that we're going to solve today. And users might not be the only things that we need to care of when it comes to the discussion about cybersecurity. But let's first scope out the system a bit more. Privacy and security are important recognized parts of the network on a protocol and standards basis. Since the early 90s, there have been considerations and protocols and practices to make sure that the internet is free and secure. But that there are protocols and standards doesn't mean it's secure yet, because a protocol is only secure as its implementation. And also the progress of technology makes it really hard to keep up with new vulnerabilities, because vulnerabilities are be found every day. Simple examples of that, of the recent times, is, for instance, the bug in SSL. The thing that makes sure SSL is the technology which is is a part of transport layer security, and it makes sure that you have a confidential relationship with a website that you visit. You might know it of the green lock in your browser. Well, last year there was a big vulnerability in SSL because of a code a developer put in there a year before, and it was only found a year after. But these are mistakes that are made in code. But what we also see is that governments are actively attacking infrastructure and integrity of packets, such as the quantum program of the NSA, which was shown by Edward Snowden, which can inject packets into your code, into the requested packets, so that you are getting other information that you might have expected. And this can run processes. This might for you and your computer to behave differently. There are of course also issues around availability. You might all know the DDoS attack. If you want to imagine what a DDoS attack is, you can simply think of phone lines again. There is an institution that has 3 phone lines open. And if people want to block that, they just keep on ringing those 3 phone lines so that other people cannot reach this institution anymore. That's exactly what a distributed denial of service attack is doing. It's requesting many websites many times at the same time, so that the server cannot process any other requests. There is an open discussion whether this is actually a part of the right to protest, or whether this is a legal attack and should be illegal at all times. But as said, I'm not going into the legal discussions today. And then there are of course many other vulnerabilities in servers, but also in your vulnerabilities. You will have regular security updates to your operating system, be it Windows, Mac, Linux, Android, or iOS. But then at the same time, you can have a very strong door, but if you leave the lock in it, or you have a very weak lock, then it might not be as functional as you would hope to. I'm talking about passwords now. And the practice amongst passwords is relatively bad. People reuse passwords over many different sites. People use simple passwords. And password cracking is relatively simple. You can, it used to be that we would crack passwords by simply trying a lot of different options. But there are much smarter options right now, which allow us to use dictionaries to guess what words would be used, or often use sentences. And if you think that replacing an E with a 3 or an I with a 1 is a very smart and strong way to protect your password, well, maybe think again, because for a computer this is very easy to replace and to try. Also, using passwords in different places might not be a good idea, because if the passwords get compromised in one place, then it's very likely that it can be tried in other places as well. But again, we're not talking about user security here, because user security is often not at the first point of the cybersecurity discussions. It's often about crucial infrastructure. And here I'll try to explain you a bit about what this looks like. These crucial infrastructure systems are SCADA systems, which is an abbreviation of supervisory control and data acquisition systems. They are a type of industrial control systems, and they're being used in bridges, power plants, gas and oil pipelines, and everything that you can think of. In research, it was shown that 99% of these systems are connected to the internet. And you think, why would they do this? Well, that's an excellent question. Often they are connected unintentionally because of bad firewall settings, but also because people want to do remote monitoring and controlling of an instance. And where there is the internet, you don't need to put on your own infrastructure. Almost the only organizations that still have their own infrastructure are railways, because they already have the cables laying next to the rails. Many other institutions are now using the internet. And this is showing the versatility of the internet. But we can also ask, do we want the control of a nuclear power plant or of a water filtration system to be managed over the internet? And if you ask yourself that question, I think it's a right one. Because if we look at SCADA systems, the level of security is generally very low. Many of the systems that were tested can be exploited with standard Metasploit vulnerabilities. Metasploit is a standard vulnerability and hacking tech testing tool, which is open source available. So even you could try it. Then next to that, many of these systems are running on very old machines. A lot still run Windows 2000 or Windows 95 even, or Windows XP. And this is because upgrades are expensive. Upgrades are already a pain for normal businesses, but when you're using a proprietary and specific build software to manage your plant or your sluice or your water filtration plant, then if you upgrade, you might break things and you need to remake the system. And often such big IT overhauls are not in the budget of these organizations. And a lot of knowledge about these systems leaves when staff is working, when staff is leaving as well. Next to that, there might not be a big awareness that these systems are exposed to the internet. But research turns out that they are connected, either directly or indirectly. And this is often also has to do with a general lack of security rules. Then there is also no hardware control, and this is even seen in nuclear reactors very often, that the computers still have their USB ports open that staff might use to charge their mobile phones, giving it a huge vulnerability. We'll talk about that later. But it also allows for people that come in to put in a USB stick and thereby infecting the machines and allowing people to take control. And then last but not least, many of these systems, when they are remote controlled, are operated via web interfaces. And when you are operating such a thing via a web interface, it means that you are also exposed to vulnerabilities that there are in the browser on the computer that you use. So that means that the threat service is not only on the system itself, but also on the computer and in the browser of the computer that's remotely logging into the system. Finally, these web interfaces that connect to these systems are often not done over TLS or SSL. So these instructions are simply sent over clear text, and these can be found on the internet. Instructions to operate a water plant. Quite amazing, isn't it? So the vulnerabilities in these systems are generally found by security researchers. Another name for these security researchers is hackers. So often in recent times in media, hackers get portrayed as these people that break systems and are a great threat. Well, most of these security bugs are found by hackers and are then provided with the big providers. But at the same time, companies and governments are both quite active in this field. So it's not the hackers where the threat is coming from, one could say. The biggest attack to SCADA systems up to now was Stuxnet, which is believed to be a project of the US and Israel against an Iranian power plant. Stuxnet was both a worm and a rootkit, spread via a USB device and a network. The worm was actually the thing that made that spread the virus, that spread the threat. What a rootkit is a program that makes sure that a system cannot be detected on your device. So while you're looking at and scanning for vulnerabilities, devices, or processes that are out of place, you won't see it because there is a rootkit installed. And that would allow the worm to easily do its work. The infection of this Iranian power plant in case was done via via USB stick and a mobile phone actually of a Iranian working in the power plant. So the threat of devices being used without to infect a network without the internet, without the network being connected to the internet, is very real. So you might be thinking about that before you plug in your phone into a system just anywhere, anytime. So whereas this attack was focused on Iran, we saw that that Stuxnet was not only in Iran, it also spread itself to Indonesia, India, Azerbaijan, even back to the US, Pakistan, and other countries. Well, this shows how hard it is to contain vulnerabilities and threats. Companies often, governments often not do this work by themselves, simply because they don't have the knowledge in-house. So that leaves companies to develop this malware. But the bad thing is that this technology democratizes. Once it's out there, it can be used by and against everyone. It's not a precision tool at all. We see a lot of malware codes being reused from other code, and malware gets inspired upon each other. Governments work together with companies because they don't have the in-house capacity, but companies do not have the same accountability levels. Think of companies like Hacking Team, Blue Code, Gamma International, and TrophyCore. Some of their customers are the US and the Dutch government, the Mexican government, but also governments like the Bahrain and Ethiopia. And this is only what these companies are disclosing or what we found out about them. Once their software is used in the wild, it can be copied and used by others. So we should strongly think about, is this what we want, and how we want the internet to be. And then there are also other infrastructure that might not be so physical as gas installations and pipelines, such as the border gateway protocol, the domain name system, undersea cables and standards and providers. These are all things that can be hacked and attacked. And if we want the internet as a critical infrastructure to remain strong and available to everyone, we should make sure that we keep these systems free. Let me quickly give you a one-sentence system of what everything is. The Border Gateway Control Protocol is the system that's connecting the internet exchange points with each other so that internet gets routed all over the world. The domain name system is being used every time you type in a website in a browser, and it then goes to this telephone book of the internet, which connects the name to the exact number of the website that you want to see. Then the undersea cables are actually a quite fragile part of our infrastructure, and we've seen them recently being tapped with optic splitters, but we could also think of them simply being destroyed, like happened for the coast of Kenya, where the whole country all of a sudden had half of its access to the internet. We've also saw governments weakening encryption standards at the standards level, and this came back to bite us actually in a vulnerability last week, where we saw that a remnant of the crypto wars in the 90s. There was in the 90s, export of encryption tools was forbidden in the US. So there was only weak encryption that could be exported. So there was still this option in browsers to use low-level encryption standards. And this was used to show how one could attack mobile browsers and could degrade the security that one requested over an SSL connection. And then with the fast internet speeds of computers nowadays, internet traffic could easily be decrypted. So here we see that when we weaken standards and when we weaken security, we do not weaken the security of one system or of one group of users or of one organization. No, we do that all over the internet, over all users. And that's what's making it a big problem. What we also seen is that there were backdoors in routers of Cisco for lawful interception. This is a very big problem because once lawful interception goes over borders and we cannot trust the hardware of the internet anymore, we have a chance that the internet might fall apart there, and that might harm the structural integrity of the internet. So we need to think about cyber defense and offense. So I said, technology democratizes. Once it's out there, you cannot get it back. And as we see, cyber defense is still really poor. Increased capacity is needed. For instance, institutionalized penetration tests of infrastructure. And this would mean that the infrastructure that we find really important or crucial, that we would test it with specific security tests, and that we would invest in both prevention and reaction force in what happens to that. CERTs and C-CERTs, which are the teams that are both there inside companies and also on a larger organizational level, are there to respond to incidents, to security incidents. So these are great when it comes to response to security situations. But these are often not more than mailing lists of very knowledgeable people, and they are building capacity on security response, but there is still a lack of official response and of an official reaction to specific vulnerabilities. This needs definitely further investments. And attribution is a very big risk and problem, and this is very risky. For instance, what we've seen in the case of Sony, where there was the big allegation that Korea hacked Sony. Well, whereas it turns out that the vulnerability was a user that clicked on a bad attachment and thus allowed the leaking. But if we're going to do cybersecurity or maybe even cyber offense based on attribution to countries, it's very hard because it's very easy to impersonate as another country or as another entity. So that's a very big risk. And what I would like to leave you with is that cyber attacks always impact civilians and the internet infrastructure at large. So we should invest on cyber defense and not so much on cyber offense, because cyber weapons do not solve cybersecurity, but improved security practices do. So I hope this was interesting to you. If you have any questions, I would be delighted to see how we could continue. Excellent. This is an excellent question. I skipped the part about open source. So there's the question: what role does open source play when it comes to cybersecurity? I think open source, both in terms of protocols and standards and software, is crucial for security, because proprietary systems can say they provide security, but this is always security by obscurity. We do not necessarily know if it's secure or if there is a backdoor. So that's why it's crucial that main infrastructure is run on open source software. And this is actually a very big problem in SCADA systems, that all the SCADA software is run by these big companies that provide proprietary software. So this is also creating a very big risk in SCADA systems, in my opinion. And that's why it's really good that all protocols and standards are developed based on open source principles. It's often confused with anonymity, but it's not the same. When I send you a confidential message, it means that no one on the line can see or hear what the message is. But this person can still see that the message is sent between you and me. They simply do not know what the message is. Integrity is when a message really is what you think that it is. So it's not been tampered with on the road. So someone could not change the content of the package to either put in a virus or actually change the message, so from yes to no. And then availability is the availability of services to make sure that they are not being taken offline, that people can make use of it. We might want to have a short look as well at the SCADA systems as they are being used by these large organizations. As you see, most of these organizations are based in Europe and the US, and Huawei is missing from this. So it's interesting to see that increasingly governments are using software based on geography of governments and providers that they trust. And this geopolitical swift and geopolitical tensions are added by recent attacks, for instance, on the chip factory ASML in the Netherlands, which produces machines that produces chips, and they produce chips as well. So there is a big risk that cybersecurity is played along geopolitical lines. And as an admiral at Google Ideas said last year, the land has been militarized, the sea has been militarized, the air has been militarized, space has been militarized. There's no reason why cyberspace would not be militarized. But there is a big reason in this, a big risk in this, because the internet is one big infrastructure, and as said, it's very hard to contain these attacks and to do precision attacks, and monitoring of the whole internet is needed. So the balancing of human rights, so balancing security and privacy, is crucial and is much harder on the internet than in other spaces. Tackling botnets irrelevant for CIIP. So a botnet is a network of infected computers that can be used remotely to do a specific task. So a distributed denial of service attack is much easier if you do it with a large group of computers. But you could also use these computers to do other kind of calculations or operations. And the question is whether these provide a threat to critical infrastructure. Well, the problem with botnets is that they really change the economy of scale, and that tackling botnets is a big issue. And the starting of the tackling of botnets starts again with system integrity and with system security, and with trying to take down the remote operators of these botnets. This can be hard, but there are also a lot of options. And as long as people use updated software, botnets can be defeated. When we look at critical infrastructure, it really depends on the issue whether they would be more vulnerable to a botnet or not. If they are providing services like a website, like a DDoS attack, definitely, that's definitely very easy to do with a botnet. But finding vulnerabilities for that, a botnet is not necessarily the right tool to do the job. So botnets are great for using spam, are great for using DDoS attacks, are great for generating more bitcoins, but for attacking main infrastructure, not so much. Well, you could think of a huge botnet doing an enormous amount of DNS requests and thus trying to bring down a DNS server, but there's so much capacity for that, and filtering of botnets based on their IP addresses and IP range has become much better. So I think that that there is a relatively minimal risk there. What is more risky with a botnet is that you have, if a botnet does a multiple of difficult attacks at the same time. So if you're under attack, what you would do is that you exclude where the attack is coming from. But if the attack is coming from a lot of different sites, then you simply might want to take your server offline, and that might exactly be what a attacker wants you to do. Or a system might reboot because it's under so much request, and that might also be exactly the purpose of the attacker. And you can imagine what kind of impact it can have in industrial circumstances. Let me please take a short sip of tea before I read out the next question. The next question is, I need to understand the protections against a security risk issue related to mobile applications. Most of the mobile applications are not meant, developed, or installed to share our data, but most of them need access to all type of data stored on the devices, including official email, media, storage, pictures, videos, contacts, my network, and Wi-Fi and Bluetooth. Even none of them are made by the security agents of government authorities. And even I have the option either to install this application or not. But why are they grabbing my data all the time? Well, thanks a lot for this question, because it's a very relevant question. When companies are gathering your data, it's much easier for other parties to access it as well. And companies are not gathering your data for nothing. And they're doing it to provide you better ads, which means, in other words, that they are selling your identity and your profile to ad bidders. And the more information, the more precise a profile they have of you, the more they can sell it for. So it is really good that you are looking at the permissions asked by phone apps. And frankly, it is great that phone apps are now saying in very simple terms which permissions they need, which information they want, because for years this was hidden in very long and difficult terms of conditions that no one reads. So it made us much easier to control these things. And there are several plugins and options on Android to give an app the idea it has access to certain permissions, but actually it has not. So there are ways to go against this, and then to even give false information to these apps or randomized information, so that you can counter how you are being profiled. Then there's a next question. Is the technology ahead of the policy or the other way around now? Well, I think both fields are quite distant from each other, and I'm not sure what is ahead or behind. because a lot of the policymakers do not necessarily understand the technology, and a lot of the technologists do not necessarily understand the policy debate. And that's a thing that we would really need to overcome, because both fields are equally hard and complex and interesting. But understanding everything at the same time is very hard, even already in one of these fields. So we need to act strategically to see how we can preserve freedom of expression, privacy, access to information, but also have security of systems at the same time. Then the next question to read out loud. Can you provide some context on the argument supporting distributed denial of service attack as a legitimate right of protest? Well, I'd be happy to. One could think of many different if we go back to the offline analogy of the DDoS attack. And that is when we would call the company and they have no phone lines available. Well, this could cause the business to have less revenue, to not be able to do business, or to cease working for some time. But this would also be the case if there would be an offline protest. There would be a protest in the street in front of a company. And if these protests are proportionate to what is happening, and if there is a form of understanding of this, this is a legitimate way of protest. So one needs to think of proportionality in that sense. Right now, we think of DDoS, and there is an excellent paper about this, and actually a whole thesis by Molly Souther. Her Twitter name is Odd Letters, and she wrote her thesis on exactly this use of DDoS attacks as an activist tool for people to make their point. So it could be seen as a form of peaceful protest even, because in a DDoS attack, essentially nothing is broken. Only a service is discontinued for a limited amount of time. So one could see this as a form of peaceful protest. Then a new question. What cybersecurity threats do civil society organizations face? Well, that's a very big question, but I would say that civil society organizations face all the threats that other organizations civil society organizations suffer from the same threats that all other organizations have, plus some more. So we've seen it on government level, that there are specific attacks both on individual human rights organizations. We've seen it in Russia. We've seen the NSA targeting specifically Amnesty International and Human Rights Watch. We've seen the Ethiopian government specifically looking at civil society organizations, and because they are doing critical work, they are immediately observed on. And here we see another part of the internet, that whereas the internet is a perfect tool for freedom of expression, it's also a perfect tool for surveillance, because we are now processing so much information in the same place. And we've also seen the hacking of webcams to make shoots of people in compromising situations that are then later be used to blackmail people into doing some things or not doing some things. So I think digital security is crucial for civil society organizations, not only because of themselves, but when we communicate, and we can maybe choose for ourselves, we are okay in doing it insecurely, but we're also making a decision for the people who we are communicating with. And people have trust in civil society organizations to protect this information, so we should really do our best to do so too. There's the next question. Pakistan has, and one final thing, this comes back to the presentation. that civil society organizations can be attacked with the same means as which other critical resources can be attacked. So in that sense, the cyber offense systems and the malware doesn't matter who is used against. So we can have treaties and saying that we will only target military infrastructure, but it is impossible on the internet to only target military infrastructure. You will always attack several parts of the internet. It will influence other services. And once the attack is out there, it might also be copied and multiplied by others. And then it's also okay to use it because another country has used it as well. So in that sense, then attacks would become mainstreamed, and that's a very big risk, which is actually already ongoing. So question 8. Pakistan has begun to carry out biometric verification of SIMs to collect and cross-reference the data of SIM owners with the national database. Should we be worried? Yes, you should be very worried. But I think you should not only be worried because of the biometric verification connected to SIMs, because SIM cards and your phone or IMEI number has a lot of information on you. Where you are, where you sleep, who you have, who you communicate with. It's a lot of information. I'm looking up. Excellent. Here, I have. You should have a look at this site. It's one guy who, and if you press play on the left lower button, you see what information they, based on what the telecom provider had, based on the telephone of one person. So you could see where he goes, where he travels, where he sleeps, where his friends are, where his probable girlfriend is, what's the contact of his MSS messages, the duration of his internet connections, and probably, well, they didn't give that, also the websites that you serve to. So that's a lot of information. And with that information, you can most probably already piece together who that person is. Linking it together to biometric information just makes it easier and makes it a more rich database to correlate. Also, a thing that we saw and that really illustrates the risk was in the Ukraine on Maidan Square, was that when people were protesting, they got an SMS from the government saying, you are in this protesting in this area, protest is forbidden. You should go away. We know who you are. Well, it's actually really good that this was used once, because we've known for a while that this information was there, but the Ukrainian government here also showed that they were not afraid to use it and to tell people. But we should understand that people are using this technology, and that it is used to profile people based on location, based on interrelation, and based on also likability, that they would do something. And that's where we get into really murky territory, where we get into the probability that someone might commit a crime, or the probability that we might better prevent this person to go into there. And these are huge impacts to freedom of expression, access to information, and freedom of assembly, because we've already seen that search behavior changed after the Snowden leaks. And you might have noticed it yourself, that you think, should I email this? Should I look this up on the web? Should I install this app? It's great that people are more aware of their security, but this means that there is also a chilling effect, which is horrible for speech. I'm almost through with my questions. So if you have no more, is there still one question? We would have time for one more, or else we can end the webinar. And I'm very thankful for your participation. If you have any questions anytime, feel free to email me or to contact me on Jabber via secure chat. There's my PGP key there. I'd like to thank you very much for your attention, and GCCS and GPD for organizing this. Thank you very much, and enjoy your day. Bye.